Greetings and welcome to Lesson 1.5, Division with Negative Numbers. Now, although we said division with negative numbers, we are going to be working with both positive and negative numbers. And the good thing about division, like last lesson we learned about multiplication with negative numbers, we're going to follow the same sign rules in division as we do multiplication. So not much more extra to learn. Just a few more examples just to get down the rules. So with division of negative numbers, let's take one step back and think about that division can be written in terms of multiplication. So let me talk about the parts and pieces of a division problem and then show how it relates to a multiplication problem. So in a division problem, I have the dividend, I have a divisor. So the dividend is being divided by the divisor. That equals a quotient. But if I rewrite it in terms of multiplication, it is the quotient multiplied by the divisor equals the dividend. Therefore, because we can change it into a multiplication problem, all the sign rules still hold true. So if my dividend is positive, my divisor is positive, my quotient is going to be positive. If my dividend, my numerator, is negative and my divisor, my denominator, is negative, then my result is going to be positive. Okay, so negative divided by negative gives you a positive. Now a positive divided by a negative lends itself to a negative. Because if I rewrote it as multiplication, that's negative times negative makes a positive. So if I divide a positive number by a negative number, my result is negative. Likewise, if I have a negative number and I divide it by a positive number, my result is negative. So let's take a few examples. 12 divided by 4. Well, 12 is positive, 4 is positive, so my result better be positive 3. Negative 12 divided by positive 4, my result better be negative because a negative divided by a positive is going to be negative. So my answer is negative 3. Now I have a positive 12 divided by a negative 4. The signs are not the same. My solution better be negative. Again, it's negative 3. Then, move myself out of the way. Negative 12 divided by negative 4 is going to be a positive 3. Okay. So I have oops. Get rid of that. There we go. We have positive divided by positive gives me a positive. Negative divided by a positive gives me a negative. Positive divided by negative gives me a negative. And finally, a negative divided by a negative gives me a positive. It also works when it's set up as a fraction and you need to simplify. So a positive 20 fifths, or 20 divided by 5, is going to give you a positive 4. Negative 20 over 5 will give you a negative 4. It should be a 20 over a negative 5 will give us a negative 4. And then finally, negative 20 over negative 5 will give us a positive 4. Now, occasionally, you might see fractions with negatives either in the numerator, in the denominator, or just kind of sitting out by itself. Well, all of those mean exactly the same thing. So, independent of where the negative is sitting if you only have one of them. It can either be in the numerator, the denominator, or out front. All of those are equivalent. So negative a over b equals a over negative b, which equals negative a over b. Likewise, if you have negative a over negative b, that's exactly the same thing as positive a over positive b, because in essence, the negative over negative cancel itself out. Remember, anything over itself is 1. So negative over negative is 1, so you can get rid of it. I know I said get rid of it, but you can actually reduce or divide it out. And because you're dividing a negative into a negative, technically that is a positive. So it does go away. So let's work with a couple of problems. Negative 15 plus 5 times negative 4 all over 12 minus 17. When we analyze the problem, I have addition, multiplication, division, and subtraction. And I can't do that division, which is really the fraction bar, I can't do that division until I have one number on top and one number on the bottom. So I'm going to work with the numerator first and get a solid answer for the numerator, or one number for the numerator. So I have negative 15 plus 5 times a negative 4. I have to do the 5 times negative 4 first. So that's going to be a negative 15 minus 20 all over 12 minus 17. I can do the subtraction in the numerator. So negative 15 minus 20 more is going to be a negative 35. And in the denominator, a negative 12 minus 17 is a negative 5. So my solution, a negative 35 divided by a negative 5. Negative divided negative is a positive, so this is going to be a positive 7. Let's work with another problem here. Negative 4 times 10 squared plus 20 divided by negative 4. Working with my order of operation, I have to do my exponent first. So I now have negative 4. 10 times 10 is 100 plus 20 divided by negative 4. Multiplication division are at the same level of hierarchy, so I'm going to do from left to right. So negative 4 times 100 is negative 400 plus, now I do the 20 divided by negative 4. A positive divided by a negative is a negative, and 20 divided by 4 is 5. So now I have, pardon me, 400 plus negative 5, so my final answer is going to be a negative 405. Just like most math, it doesn't live in the number world. We talk, and so when we communicate by words. So we do want to work on translating words or written language over to math symbols. So what number do you divide by negative 5 to get negative 7? So my problem setup is I don't know what number, that's going to be my unknown. I divide by negative 5 equals negative 7. But remember, with a division problem, I can rewrite it as multiplication. It would be the dividend equals the quotient times the divisor. So x is going to equal negative 7, apologize for my writing there, negative 7 times negative 5. Negative 7 times negative 5, negative times negative is a positive, 7 times 5 is 35. So my unknown value is going to be positive 35. What number do we divide by 6 to get to negative 7? So again, my setup of the problem, I don't know what number I divide by negative 6. Pardon me, positive 6. equals negative 7. And I think the easiest way to solve this at this point is to translate it over to multiplication. So it's going to be the dividend, the numerator equals the answer times the denominator. Therefore, our unknown is going to equal negative 7 times 6, which is a negative 42. So that's it for this lecture. Just follow the rules of multiplication with negative and positive numbers. You're going to use those for division, and you shouldn't go wrong. So until next time, be seeing you.